Hey, what's up, people? Was doing a bit of shopping at a store recently, and I came across this Flicker Flame LED bulb that's branded by GE. And I've seen some of these before. They're usually like kind of big, and they have like the standard like E26 bulb base. And inside of those, it's usually like a little cylindrical arrangement of LEDs, and they kind of do like a flame sort of pattern and stuff. But this one caught my attention due to the fact that it was a lot smaller, and it actually has a candelabra base. It claims to be a 1 watt non-dimmable, and it flickers like a real flame. Which brings me to a little warning if you're sensitive to like lights flashing and stuff like that. Um, this is a kind of a warning because there is going to be some flashing in this video, and I'll let you know ahead of time before I like put up anything. But I do know that obviously it flickers, so there will be a bit of a light flickering and flashing. So yeah, just be warned. Okay, so it comes with a one bulb. If we look here on the side, it claims to last 13 years based on 3 hours used per day. It says that you get a limited warranty of 5 years based on the rated life of 3 hours used per day at 120 volts. I don't know how much of a hard time they'd give you if you try to do a warranty claim on this. It says if this bulb does not last for 5 years based on 3 hours per day, 7 days per week, return bulb, proof of purchase, and your name and address, blah, blah, blah. So, yeah. I don't know. I guess if you kept like a record of how much you actually used it, what hours, what days, and all that stuff, to keep a an accurate record of stuff. Yeah, I don't know. But anyways, multi-direction flicker flames, so you can have it like right side up, you can have it upside down, and the flames will always look like they're going, in that direction. And I guess it's not actually made by GE. It says it's manufactured for Savant Technologies LLC, Nola Park, Cleveland, Ohio, all that stuff, made in China. The images have been enhanced to dramatize the effect of the bulb in use. I mean, I would I would think so. I don't think you'd actually want to see a fire coming out of your bulb here. Yeah, definitely not actual flames. Not evaluated for use with emergency exit fixture or emergency exit lights, and I don't know that anybody would actually want to use it for something like that. It seems like it would be a bad idea. I mean, imagine you're in a building that's already on fire or something like that. You're trying to get out, and you see that you're, oh no, the emergency lights are on fire also. So, yeah, don't use it for that. All right, so let's go ahead and open this up, take it out of the package here. And there is the bulb. So as you can see, we've got this flat arrangement of LEDs right here in the center. And one thing that I noticed that I hadn't kind of noticed before is that one side appears to be a little thicker than the other side of that yellow stuff in there. It looks like this side here on the right is thicker than the one on the left. The actual bulb itself is not glass or anything. This is all plastic. It's kind of like amber colored, and they also kind of made the base sort of like tan, kind of amber colored also. And before we actually open it up, let's go ahead and put it in a base here, and we'll see what it looks like. And be warned that, there is going to be some flickering right now. So here we go. I'm going to turn it on. Hello. There we go. I think this switch is kind of faulty or something. Anyways, on camera right there, it actually looks a little bit better than it actually does in person. If we look at it from this other camera here and I turn down the exposure, you can actually see how the LEDs are actually arranged in sort of like a pattern of 4 on the bottom, 3 on top, and it's got 6 sets of those, like all the way up that little plate inside. And what I mean is that it's something like this. So it has like these 4 LEDs here and then 3 LEDs here, and all of these light up at the same time. So it's got 6 sets of those going like all the way up the bulb. And also you can see here how right now it's going up because I have the bulb right side up. But if we turn it upside down, then it flips over and now it's going from down here upwards. So you can see how as I flip it here, it switches directions. And it sounds like it has a little ball or something inside because something actually rattles in there. You can hear it move when you flip it over. Now I'm going to show some footage here that I recorded previously of this thing kind of sitting here in the dark on the bench. And it is, flashing quite a bit, so just be warned about that. But it actually doesn't look too bad if you look at it from a distance. It actually kind of does a bit of a convincing effect. My only little gripe is that it kind of seems a little bit repetitive. Like it kind of rhythmically like pulses, and then, it'll do kind of like more of like a steady of looking, like part of the flame. but then after that it goes back to pulsing. So it doesn't appear to be all that random. Like maybe it's just kind of basically got like a pre-programmed pattern that it follows. I think it would have been, maybe a little nicer if it was somehow the microcontroller in here was able to like, completely randomize the pattern by like picking up maybe like some noise, from the atmosphere or something. But yeah, it doesn't appear to do that. And also, as I mentioned, in person, you can actually see like all the little individual like LED elements in there on the plate. But if it were to be like in a fixture or something with something like diffused over it, I don't have like a little fixture that I could have put it in, but I just sort of put like this like a translucent opaque little tub over it just so we can see what that looks like. It does, kind of do a bit of a convincing flame looking sort of a light, but yeah, it's not terrible. It's just if the pattern were to be a little better, I think it would be a lot nicer. But I mean, overall, it's really not that bad. All right, so well, let's do the thing we're all here to see. Let's go ahead and open it up and see what's inside. Now, when I first took a look at this and I saw that it had like a bunch of lines going up here into the LED area, I thought that maybe this was going to be like a matrix of LEDs. And, it would be able to just kind of like individually light them up, even if they're like, multiplexed or something. But there's a total of 7 lines running across this. And I mean, that kind of makes sense if you have a total of like 6 blocks of LEDs. I don't know if they're actually on both sides. Like each side has its own like sets of LEDs. I'm guessing so because we see that we've got 7 here and we've got 7 here. And as I said, this isn't really like a matrix. So I'm guessing it's going to have like one common, and then it's going to have the 6 that light up each one of those little blocks. But we'll take a look inside and see how that's actually wired. Oh, and one thing I wanted to show you real quick. You see that right there? Yeah, that was my bad. My kid actually wanted to see what this looked like, and I hadn't like dug out this little base here. So what I did was I just had some bare wires here. And I told him, I said, I'm going to do this. It's a little dangerous, but just so you can see it working. So I kind of touched it like that. Right now, this isn't plugged in, but so I kind of touched it like that. And, he was able to see what it looked like. And, oh, and in his own words, he said, I thought it was going to be a little cooler, but it's not that cool. When he saw, that you can see like all the little individual LEDs in there, he thought it was going to look a little more actual like flame-like. But anyways, yeah, I accidentally shorted the wires there together, so I burned a hole in that. But luckily, I didn't damage the bulb, so it's still working. But let's get a little tool here. We'll see if we can pry the cover off. That does not want to come apart. I'm wondering if it's actually glued in place. See if maybe we can coax it to separate by squeezing on it. Ah, there we go. It's coming apart. Maybe I can just pry the rest of it off now. So, yeah, it looks like maybe there's some adhesive in there. There we go. It's gone. All right. And it looks like this will come off. Yeah, there it goes. Got to pry up on a few sides, it looks like. So it's got one little tab there, 2, 3. Oh, I see. Okay. So these 3 pins here look like they might just be providing power to this top board here, and that's going to be the microcontroller. And then we've got a few resistors along the perimeter right there. So this might be able to push out. Yeah, it's also got 3 little tabs there holding it in. All right, we got 1 tab to release right there. Second tab. Maybe if I can just squeeze this and push it out. This one on this side is being kind of difficult. Well, shoot. I was trying to get the tool in here so that I could separate that side, and I leaned it a little too hard up against the bench, and I broke this part. And turns out this actually feels like glass. So the LEDs are mounted on glass. And let's see if we can remove some of this lens stuff here. We'll deal with that in a bit. See if we can get the rest of this board out of here. So I get that side up, and of course this side here had to snap back down. There we go. All right, now I can push the rest of it in here. Oh, and it turns out that I could have just pulled out the... Yeah, I could have just pulled out the LED side here. This looks like it's just a connector. Well, that's kind of unfortunate. Even though I think if we were to like touch the contacts here on the glass, we could still get the LEDs to light up. I don't know what kind of voltage it's using. But yeah, that's the control board itself right there. And we can also see how we've got 1, 2, 3, 4, 5, 6. Yeah, a total of 6 transistors right there. So those are probably going to be driving like the negative side. I have a feeling the positive side is probably the common. And this little microcontroller right here is just going to take care of turning on these 6 transistors right there. Man, I was kind of hoping to keep this intact, but yeah, my bad. I leaned it a little too hard on the bench and it broke. So the actual sensor or the little switch that determines whether it's right side up or upside down is on this side of the base. It's not on this side. So one of these pins probably lets the microcontroller know whether it's facing, like upside down or if it's right side up. So we can actually check and see what kind of voltage we get out of the little power supply in here. And looks like the middle one there is going to be positive. That one there, the most innermost one, is going to be the ground. And the outer one looks like that's probably the one that's indicating whether it's upside down or right side up. So before I damage or do anything to the bottom of the base here, let's see what kind of voltage we get. All right, so I'm going to try to be really careful. What I'm going to do here is I'm going to stick these pins into this connector right there. That way I can get my multimeter leads and just touch individual ones without shorting anything else out. That way I don't risk damaging it even further. The switch on this is off right now. Okay, we're going to have to flip this over. Like that. So those 2 inner pins are the ones that I want to check. All right, so I got the multimeter up there. Let's go ahead and turn this on. Hopefully it actually turned on because it seems like the switch isn't working very well. And as I said, the innermost one appears to be ground. The middle one appears to be positive. And it's only providing 5 volts. Wow. I thought it was going to be something higher, but I mean, if it has the power of the microcontroller, I guess that makes sense. So, very low voltage. All right, so let's go ahead and pop the rest of this out. I think there might be a wire that's going to be soldered onto that little blob on the end right here. I don't know. It might be better off just removing the rest of this screw base right there, because there's probably going to be a wire that's like pinched in there somewhere. Or actually, looks like if we just solder that terminal right there, and this one right there will release the alive and neutral. And why is this end backwards? And also, I bent the tip of my tweezers there when I was trying to pry open that board off the top side. But while we're here, those are all the transistors. We can see that they're all the same, 72kC. Not really sure what that is right off the bat, but they're probably going to be like NPN transistors. And then we've got 152 ohm resistors going to the base of each one. Or they could be MOSFETs also. That there's the microcontroller. It says BJ8M 608AJC. No idea what that is. Could be just some like totally custom IC. Okay, so the neutral had a wire going up to it, but the live, that's just a test point. So that's not where it actually goes in. So I got to figure out which one it is. Okay. I think this is actually going to have like a fusible resistor, the way that other bulbs have it. So I think it's this one right here, actually. But it's not labeled, so I'm just going to try to desolder it and then see if I can pull the board out without any fuss. All right, there we go. Now let's see if it'll come out. So I'll just go around. Yeah, that came out without any issues. Yep, there it is. So, yeah, there's a fusible resistor in here. And then we see that the other wire just goes directly to this one here is going to go directly to like the screw base. This one's going to go to that center pin. So that's what's inside of that. And on the board, let's see what's on the opposite side. Got a bunch of, got 2 capacitors, inductor, 2 inductors, another metal film cap right there. That little metal can right here, I bet you that is the tilt sensor. So what it probably has inside of that is like a little ball that either goes like up over here when it's upside down, or when it's right side up like this, then it makes contact against like two terminals on this side. We'll see if that's the case. We can remove it and test it out. That there's going to be the little switching IC for the voltage regulator. So that's going to be stepping down the 120 volt mains down to a 5 volt. Looks like we've got a rectifier right there. Sure enough, we do. And yeah, there's really not a whole lot on this board. So it's basically just going to be like a buck converter. And that's the regulator right there. That's a BP2525. And it's a very simple to wire device. I actually found the data sheet for it. And that's it right there. I think this is Chinese. I'm not sure, but we see right here, we've got a diagram for it. So we've got the input rectifier right here. We've got a little bulk capacitor right there. That's the actual device itself. We got a couple more diodes on this side. This is just a non-polarized capacitor, resistor right here. So that's probably CS is probably like current sense. Another inductor right there, another polarized capacitor, a resistor here on the output. And if we take a look at the actual board that we have, we can see right there we've got some resistors between what appears to be the drain. Actually, no. According to the data sheet, this would be pin 1 and 2. So it looks like between ground and select. If we take a look at the data sheet here, we see we've got those resistors between these two pins. But that looks like it might be this resistor right here. So let's see. Does the other side go to 5? So we got 1, 2, 3. This is pin 4, and that's pin 5. So yeah, that's going to be the current sense resistors. And then we have one of the inductors right here. Actually, on the schematic, it only shows one inductor. The other one's probably going to be for like just smoothing the output or something. And then we've got our two capacitors. So this is a 6.3 volt, 220 microfarad one. So that's going to be for the output. And sure enough, right there, it says 5 volts. So that means that this other capacitor over here, that's going to be the higher voltage one. Let's see what it is. So yeah, 250 volt. You can see it right there. And let's see if we can move this out of here. So 22 microfarad. And you can see how the terminal there, that's going to be one of the terminals of this tilt switch. The other one's going to be the center. On the other side right there, it does say right there, switch 1. So yeah, not a whole lot of stuff on here. We see right here, it says F1. So that would be a fuse, and that's where it connects. That's that fusible resistor. That there is just going to be the rectifier. So we get AC in on this side, and on the other side, we get rectified mains. So that's going to be about 165 volts coming out of that side. So a very compact little 5 volt regulator here to go from mains to 5 volts. I don't know at what sort of currents. Let's see if it says on the data sheet. Oh, and regarding that select pin, the reason it's grounded is right here. If you ground that out, it provides 5 volts. If it's not grounded and it's just up to VCC, then it provides 3.3 volts. So it looks like it can provide 2 voltages output. And according to this chart right here, if I'm interpreting this correctly, let's see, we have I'm not sure which version of this chip we have here, because there's an AH, there's a B, there's a CH, a D, an EH, and an F. All right, so I'm trying to use Google Translate here to see if I could figure out what sort of chip we got here. And if we look right here, we see that we got ZZ, ZZ, WW, and X. And it looks like this X here might actually be what identifies what kind of chip we have. It looks like X here stands for a current gear. And on the chip that I have, it's an A marking. On this list here, there is no just A, so I'm going to guess that it's probably this one then. So at 5 volts, I'm guessing this would probably be minimum, and this is maximum. Let's see if this will tell us anything. Continuous, there we go, pulse current, volt out 3.3. Oh, here we go. Okay, so continuous current volt out at 5 volts. Is 150 milliamps. Pulse current at 5 volts is a second. It says, oh, whoops, because I have the mouse right there. There we go, 200. Internal MOS tube limits. I'm guessing that's the maximum current. Oh, well, yeah, this is right there, maximum current limit. So 350 milliamps. So looks like that's what we're looking at there. Continuous of 150, 200 pulse, maximum 350. So I guess that sounds about right. I mean, you wouldn't really need a whole lot of current for these LEDs. And I tried looking up the 72 kc for these little SOT23 devices right here. And it looks like those are this right here. It's SMS72KC and channel enhancement mode MOSFET. So yeah, MOSFET's a 60 volts, 300 milliamp. And I mean, not much to say about these other than just looks like just some like multi-purpose MOSFETs. They got the gate there, the source, the drain. So just basically being used as you'd expect a MOSFET to be used. And since I've already damaged the little glass plate here with the LEDs beyond repair, looks like the glass kind of broke right there as well. This side here is the one that does not contain the LEDs, so they're going to be on the other side because that's where the traces are. So if we scrape this side of the material off, let's see what we can learn. I'm just going to try to be careful here and go down this way, peel off this yellow material. Ah, there we go. So we can see how we've got like one terminal that runs along this way like that. So yeah, we can see how each one of these goes to one pair of the LEDs. And you can see right there where the glass kind of broke. So let me finish peeling this off. Right, there we go. So looks like this terminal right there, that's the common for all of the LEDs. So that's going to be the positive side that goes to every single set of LEDs. Looks like they are actually, are they in parallel? As best as I can tell, looks like the way the LEDs are going to be arranged is that there's going to be one set that goes from like this trace here to that trace right there. And then the next set is going to be from this trace right here to that trace right there. And you can see how this would make up like one set of like the 4 and the 3. The next set of 4 and 3 is going to be like right here. So that's this would be the third set, the fourth set, the fifth set, and then the sixth set would be right there. I don't know if I'd be able to peel up the other side and we could actually take a look at the actual LED elements themselves. I might actually end up like scraping them all off if that's if I try to like peel off. But let's see what happens. I mean, this is already all damaged up. Can't really harm it anymore. Let's see if maybe I can peel off this entire filter right here. And the glass is breaking right there. Ooh, there we go. Well, I think I peeled off a good amount right there. So they are tiny. So that's the best magnification I'm going to be able to get right there. You can see how there would have been a bond wire attached from like one terminal of the LEDs to one of the traces there, and from the other terminal there to the other trace. So I think that those are the actual LEDs still on the glass there. I don't think that any got pulled up on this yellow filter material. Let's see. So no, it doesn't look like there's actually any diodes on here. The bond wires for sure are probably running through this stuff here. So like on each one of these, we probably have a bond wire that's inside of the material, like say from like this trace right there over to that side, although I can't really see it. But yep, that's what those are right there. Wonder if we can try lighting one up. All right, I got my multimeter here set to diode check. I'm going to see if I can carefully touch both sides of one of these diodes. And if I'm correct, this side here should be positive and this side here should be negative. Let's see if this will light it up. Ah, there it goes. So it's extremely hard to keep a consistent contact on one of these. But you can basically see how they are just the blue LEDs, and it's that yellow filter material that actually makes them look white. Yeah, it's way too tiny. I can't really do this. I'm recording this after the fact because I completely forgot about the tilt switch. But you can see right here how I've got two of these clips, one going to each terminal of that switch. So if we have it like this, upside down, I'm going to start the capture on the meter here, even though I already have it connected, but I forgot to start it. There we go. Is this working? Okay, it's working now. All right, so right now it's wide open. When I flip it over to the other side, it's going to make contact. There we go. It doesn't seem to be crazy consistent. There we go. So it jumps around a bit. I guess we can open it up and see what's inside, but it's probably just going to be like a little ball bearing or something, and it's making contact against the can and that one terminal on the end. So yeah, let's see. Looks like the bottom is just crimped on there, so maybe... Oh, there it goes. That didn't take much work. Oh, so it turns out there's two balls. Yeah, there we go. So it's got two little balls in there. They look like they are gold covered. And then there's a single terminal right there on the end of that. So that actually makes a little more sense, because I was thinking about how, if the ball here was like just barely making contact against the can, it'd be a little hard for it to get like a constant continuity. But since it's got two balls, that means that one can be kind of like offset, the other one can be kind of like pushing on it, and then that way it gets a little bit better contact between the can and that single terminal. So yeah, that answers that question. And just in case my explanation sucks, here's actually what I mean more visually. So when we have that sensor, or that tilt sensor upside down, we'd have both balls like being down at the bottom of the can like that. We've got that little middle terminal there, and you can see that we have like no continuity between the can and that middle pin. So the switch is wide open. But when we flip it right side up, now we can see that the balls, they can kind of like situate themselves a little bit, like, like offset like this. So this one here kind of putting a little bit of pressure on that one so that it can make better contact between the can and that center terminal. And that's how we get continuity across the two terminals. So hopefully this actually makes a little more sense, in case my explanation was unsatisfactory. And best as I can tell here on the board, it looks like this here is going to be like the ground. And this pin is actually the one that goes to that terminal right there on the pin header. So it looks like it's just pulling down this terminal to ground when it's like upside down. And that's how it knows to change the direction of the LED patterns. And so, yeah, there we go. So that's what's inside of one of these smaller flickering flame flicker LEDs. Kind of sucks that I broke this, but I mean, we actually got to see what was actually on the glass there. So I thought it was actually pretty neat. And so the thing that's actually making it look yellow would be like this filter up here, because it's not like they're going to look white. And I wish we would have I wish that I wouldn't have broken it before I got a chance to test it out. We might have actually seen that all these LEDs would have looked white. But I mean, oh well. And this thing cost total of like $8.99, not including taxes. So like a $9 each one of these bulbs. So it wasn't exactly totally cheap, but it's not like it was that expensive or anything like that. The thing I was the most surprised to see was that it actually uses 5 volts to power up all these LEDs. I thought it was going to be something higher, maybe like, I don't know, 80 or something. But then again, there's not that many LEDs on each one of these segments. So I guess that makes a little more sense. But yeah, I hope that at least this was kind of interesting. And thank you all for watching once again. I'll see you guys around the bench.